All right, welcome back to the course. So we had just been working on preventing our tree from overfitting using the min samples leaf. And we were observing how it works, right? We were getting smaller trees that were less overfit, but um, we were basically determining the performance by using the test data. We were fitting the value of min samples leaf using the test data. And we know that's wrong. So we want to use cross validation. Now, when we're fitting the regularization parameter for logistic regression, we had a special logistic regression function from scikit-learn, actually a special class from scikit-learn called logistic regression CV. So the cross-validation loop was built in to the function itself. So if you remember, right, we used logistic regression CV to make the model and then we fit it. So part of the training of the model incorporated cross-validation. We don't have that for the decision tree classifier. So what I mean is there's not a decision tree classifier CV that will incorporate cross-validation into the training, but we do have something called grid search CV. And this is a class that allows us to make a grid search CV object that we can actually use with any model. So we could actually use this with logistic regression, but we can also use it with decision trees or any of the other models that scikit-learn has. And so what it will do, essentially, and you'll see as we go through this, but what it'll do is it'll take any model, it'll take a whole set of parameters that you'd like to test. So for example, with regularization, right, we tested a whole list of regularization values. Here, we might test a whole list of values for the minimum samples leaf. So the grid search CV object will train our model with each of those values using the cross-validation method to determine the performance of the model. And then it will save all the results so we can explore them. And then it will also find the best settings for the parameters. And it will then retrain the model on all of the training data with those settings for the parameters. Let me kind of walk through that here. So first thing we need to do is make our model just like we did before. And we only want to set parameters that we're not going to try and search over. So I wouldn't actually want to set min sample leaves here because that's one that we're going to change and see which value is the best. So you only want to set arguments here that will be fixed for all of the different models that you're testing. So here it's just that we want the random state to be 0. So we create our decision tree object, and here it is. And then we want to create this dictionary of keyword arguments for the function. So min samples leaf, this is a keyword argument for the function. See, it's the exact same one we used previously. And then we provide a list of all the values that we would like to test using cross-validation. So I've just made a list that goes from 5 to 100, and I'm using the range function to do that automatically. So just to see what that looks like. So range actually returns an iterator, but if we just want to see all the values at once, we can cast as a list. And so this is what we get. This actually generates a list from 5 to 100. So just instead of manually typing that out, it would take a while, right? I can just pass this. But just to be very clear, you could just type the list of the values you want to test, right? Or you could generate that some other way. But to save time, I'm using the range function. So what this is it's a dictionary with only one entry because I'm only testing one parameter right now. So the only parameter I want tested is the min samples leaf. And the values I want to test are every value from 5 to 101. Note that we can test more than one parameter if we'd like. So I could do min samples split. And let's say I just want to try 3 different values for that. I might say 40, 80, and 120. I don't know, 120. So you can actually test as many parameters as you would like at the same time, as long as those are actual parameters to the function. So they have to be actual arguments you would pass to the function class here. And it'll test every combination. So you can see this can get really crazy, right? If I have, let's say I had 100 values here. So I have 5 to 100, so it's really, I guess, 95, right? Or 96 inclusive. So 96 values here. If I did another 96 over here, the combinations would be 96 times 96. So not exactly, but approximately 10,000. So that's a lot. So the training is going to take a long time. It's going to train a model for every combination of those values, and it's actually going to train over the cross-validation loop. So here we're dividing our training data into 5 parts. So the cross-validation loop itself is 5 different training sessions, really 5 different models. So it's training the model for every parameter setting, for every cross-validation fold. So it can it can take a while if you have a lot of parameters, but for our purposes, we are just going to try one parameter. This won't take as long. Okay, so now we can create our grid search CV object. We pass to it the model, right? Here's the model that we would like to test for all these different values. We pass the parameters dictionary. We pass how many cross-validation folds we'd like to use. So you can also pass other things here. There's advanced cross-validation things you can pass here, but to keep it simple, you can just pass a number that will determine the number of folds you'd like to use. So here I'm using 5. This is what we use with logistic regression. And then if you'd like to also return the training score, you can set this to true. So if you want to save the score on all the training sets, you can set that to true. And I'm setting it to true just so we can see it. You could also set it to false. That would be fine. And now we've made this grid search object. So just to be really clear, we could have done this with logistic regression. So if we had made a logistic regression here, and then in our parameters, instead of min sample leaf, it would be the C parameter, right? And we could have actually used the grid search CV to find the best value for regularization. But we use the built-in logistic regression CV instead. Okay, so once we've set this up, we can actually call fit on our grid search CV object, and it will then fit the model for all the parameter values over the cross-validation folds on our data. So let's do this, and it takes a few seconds. It doesn't actually take that long because it just trains very quickly. And then we get this grid search object, and because this is on the last line, it just prints out the grid search object and the parameters. So just showing the different parameters for this. Okay, so now we can explore the results. So let's just go right into this. So we've trained it. We actually just trained our decision tree model for all of these 96 values of minimum sample leaf, or min samples leaf, over the 5 cross-validation folds. And so now let's explore the data here. And you can actually get the results from this CV results attribute from the object. And this returns a string, or not a string. Actually, let's just look at what it returns. So it returns this dictionary, this key value dictionary, but to explore it better, you can actually pass that right to the data frame constructor from Pandas. Basically, you can convert that to a data frame. So let's see what that looks like. So I've now taken the results, which is in this dictionary format, converted it to a data frame to make this grid search results data frame. And now I'm just using the head method to print the first few lines. And let's look at this. So there is a row for every parameter setting. So when min samples leaf is 5, let's just see what we have. So it's 5. So this is not a very strong setting. It's still going to overfit quite a bit. So if you look at the mean score on the training over the cross-validation data on the training part, it's this is an accuracy score, by the way. I will come back to that in a second, but it's about 86%. And on the test, it's about 64%. We can also see the mean time to train the model and to actually run the scores. And here you can look at the testing and training scores on each split of the cross-validation data. So there were 5 splits. So this goes all the way from split 0 to split 4. Um, you can also see the rank. This is going to be ranked by the mean test score. So minimum sample leaf of 5 is actually 92 out of 96. This is very low ranked, right? This is if we were to, well, as we'll see, there will be other settings that have a better mean test score. Okay, I wanted to come back to the score here. So with the grid search CV, you can actually pass, there's a score argument, or it might be scoring. Let's actually take a look. Let's take a look at the docs. It's always good. Okay, it's actually a scoring parameter. So you could actually pass a different scoring function if you wanted to, but if you don't, it will use the built-in function, the built-in score function for this the decision tree object, and the default score function for the decision tree object is just accuracy score. That's just the default score for the decision tree classifier. So that's why when we see the score here, it's accuracy. It's using the default score function for the decision tree classifier. But you could change that if you wanted to. All right, so now let's just use some of what we learned in our data analysis course to grab the results where the rank test score is less than 10. So we're basically looking for the top 10 results. And let's look at them. And we want to sort the values by the rank test score. So here are the values. You can see the rank is sorted by score, and it's where the rank score is less than or equal to 10. So the reason this looks weird is because you have a bunch that are tied for first place, and then you have a bunch that are tied for 10th place. So that's why we're actually getting more than 10 here. But if you look at the mean scores, it makes sense. If you look at the mean test score, they're all the same here for all these different settings. So they're all ranked as 1. And this could be for a few reasons. It could be that you could change the minimum samples leaf, and it might not actually remove any splits. What I mean is, you change it from 42 to 43, you could actually end up with the same tree. Just depends on what the sample size is of the leaves. So it could be that these trees aren't really changing much from 37 to 45, or it could be that it does change, but the mean accuracy remains the same because the predictions are actually the same. So we have learned how to explore, right, the performance for the different parameter settings. And now we can get the best one. So how do we get the best one? Well, it's pretty simple. First, you can always look at the params for the best one. So we see it here. We actually see there's a bunch tied. So it'll be interesting to see which one that it chooses. What we'll find is it chooses in order here, it chooses the first one, so 37. In fact, let me just run this, and then I'll go through the code. So I printed out the best params attribute from our grid search CV object. That gives us the best params. In this case, it's saying 37. Although you'll notice we could use 45 and it would be the same. And then we can also get the best estimator. So after the grid search is done, it will then choose the best parameter. In this case, it chose 37, and it will train a model using that setting on all the data. So no more cross-validation folds. It'll now train on all of the training data to get the final model. And you can get that by it's stored in the best estimator attribute. So the best estimator attribute from the model here actually stores that final model that's trained on the best parameters. In fact, you can just see that. So if we just evaluate this, it'll print the output, and you can see that attribute, that best estimator attribute, is actually a decision tree where the minimum samples leaf right here, right, is 37. Of course, that's the value that it determined is best. So if we save that to a variable name, I'm just calling best tree, then we can do all the stuff we've learned so far. We can perform, we can use the graph viz string to create an image of the tree. We can also, now finally, we can correctly look at the performance on the test data. 76%. So it's interesting to go back and compare that to the logistic regression data, right? That'll be a question on the quiz. So our decision tree model has an accuracy of 76%. And remember, so far we've trained it on the training data without removing the grades where the students had a grade of 0, right? We haven't removed those. Last week we did because we said those probably are outliers. We haven't yet. That'll be part of the quiz to retrain a decision tree on the data with those removed. But if you were just to compare the apples to apples models here, so compare this decision tree to the logistic regression trained on all the training data, which one did better, right? Which one did better on the test data? It might be the one you want to use live. Okay, in the next video, we will look at the confusion matrix and the classification report for this model.